Hi, this is Angela Rasmussen from the University of Utah Department of Electrical and Computer Engineering, and I'm going to go over some examples today. So we're going to do problem one from the notes that are posted on Canvas. I just wanted to recap quickly the steps, and then there's a little video that shows the steps. So in this case, we're actually going to find a different variable in the circuit than the voltage over the capacitance or the inductor current. And so we're going to do one extra step, which is to draw at 0 plus. We're going to do this blue highlighted step. And so first we're going to do initial circuit, find VC. For this one will be a capacitor circuit, so we'll find VC. From there, we're going to change VC to a voltage source and find the initial value of the circuit when it's in its second position, which is 0 plus, right after the switch has happened. Then we're going to do the final circuit and then find tau, and then we'll write the general form equation for this. So this is our problem. And in this case, this was the one we solved in class. So now we want to find I'm going to call it I2, and we're going to do it for, again, t greater than 0. And I2 in this case is going to be located here. So we're going to redraw this circuit, leave out the element of the capacitor element and then the switch, and then we're going to determine what position they're in. When we look at the switch is open up first, and then at 0 it closes. So right before that event happening, the 0 minus will be when it's open. So we're going to leave this just open here. Capacitor sitting for a long time is also open. And so we're going to find this VC. As we can see, a floating node, all of those are floating nodes, so all the currents are going to be 0. And with that being 0, there's no current flow here, so the top is going to equal, or actually be, the same node as on the bottom, which means that VC will be equal to 0 volts. So this part 2 of the initial step is when we have a variable that we are trying to solve instead of just VC or IL. So what we're going to do here, which is the difference, is we're going to replace that capacitor with a voltage source. And in this case, it's 0 volts, which makes it easy. But if it wasn't, then we would put in the actual voltage that we found in the previous step, 0 minus. Here we're going to determine what the switch has done right at 0, or right a little bit right after 0. So in that case, it's already closed. So with that 0 volts across a resistor, we're just going to ignore this because it's giving it 0 volts across it, which means it's got to have 0 current there. So I2 is labeled here. And again, if we do node voltage, the plus side of this is going to be 20 volts. And the minus side is going to be 0. So I2 is going to equal 20 over 2K, which is going to give us 10 milliamps. So this is going to be our initial value. Note here that if we look at this, I2 in this case is equal to 0 at 0 minus. But again, we're trying to find it right after the switch, and then kind of after that time period. So 10 milliamps will be the value that we will use for the initial value. For the final one, we are again going to draw the circuit, and then from there we determine the switch position. And in this case, again, it's closed, and the capacitor sat there again for a really long time. And we are going to find I2 in this circuit. So from that, we are going to take that I2 is equal to 20 minus 0 again. And in this case, I forgot to draw the grounds, but this would be my ground location. So that would be where the 0 is. And then all the resistances between those nodes, between 20 and ground is going to be 2K in series with 4K. So we get 6K. So up here I forgot to draw, that also had ground. So that's why the ground was 0. And then this is 20 over 6K, which is approximately 3.33 milliamps. And this is going to be our final value for this circuit. The last step is finding tau. And remember, for tau, you're going to use the final position. Redraw the circuit again, leave out the element and leave out the switch. And then in the final position, the switch will be closed. In a final position, capacitor sat there a long time, so it is again open. And in this case, we go A to B, or sorry, we don't need to determine if it's open or closed. So for tau, we are just going to label A and B between wherever the element was taken out. And then we're going to remove any independent sources. So as you can see here, I already removed that one. So V equals 0 means a short. And so that's why that was a wire there. And then our pathway comes up and then it splits, which means a parallel configuration. So whatever each branch resistance, if I need to condense that down again, I can condense those, but those two pathways will be in parallel. So I determined that RTH is 2K in parallel with 4K. And I can write that as either 1 over 2K plus 1 over 4K, or it's the same as 2K times 4K. Combining the common denominators on the bottom gives me then, and then those flip up to the top. So 2K times 4K, and then 2K plus 4K. So reducing that down becomes 4/3 K. And tau is going to be RTH times C. And so 4/3 K times C was 2 microfarad. So I put in 2 times 10 to the minus 6. And K is 10 to the third. And so that ends up giving me a tau of approximately 2.67 milliseconds. And now the general form equation of I2 of t is going to equal the final value, which was 3.33 milli, plus the initial, which was 10 milli minus 3.33 milli, e to the minus t over 2.67 milliseconds in amps. And this you can write as 4t greater than 0, or you can write u of t, which is the step function, which means that it's just going to be valid after it's 0. So either way, you can just say 4t greater than 0 or u of t. And this would be our answer for this problem 1. Thanks for watching.